Still delays for the launch of the Webb telescope. But anyway, here we are now. We start on Christmas. The James Webb Space Telescope team is working a communication issue between the observatory and the launch vehicle system. This will delay the launch date to no earlier than December 25th. We will provide more information about the new launch date no later than Friday, December 17th. With this brief statement, on December 14th, NASA announced yet another postponement of the launch of the Webb telescope, until then scheduled for December 22nd, setting the new date to a vague no earlier than Saturday, December 25th. What's going on? Is this just a setback, or should we prepare for worse surprises? Two postponements of months has already happened in the past. The wait for a mission start that seems to never to arrive is becoming exasperating, even if we have to understand the caution elevated to the nth power when the success of a $10 billion mission is at stake. For most missions, the launch constitutes the major part of the risk. Although this may not apply to the Webb telescope, which once reaches space, will have to perform in total autonomy 50 implementations to configure the huge system, with hundreds of individual operations that will have to work perfectly for the mission to succeed. Okay guys, at the moment, it's useless to look too far ahead. What would you say if instead, to get rid of the nervousness, we try to understand what exactly is the situation? Maybe going through the timeline of the preparations in progress at the ESA base in Guyana. Apparently, it all started December 12th and 13th, when during a routine test, a communications issue was detected between the telescope, already folded and positioned on top of the Ariane 5 launcher, and the ground control center. The problem manifested with the loss of data at some point of a cable about 100 meters long that now technicians are examining inch by inch. Similar problems were also found during the recent launches of the DART and IXPE spacecrafts, and in those occasions NASA had anyway authorized the departure. A matter of economic investment, the DART and IXPE launches cost taxpayers only $330 million and $214 million, while the James Webb nearly $12 billion. Rightly so, for the big telescope, there's no rush to launch, and everything has to be perfect. In order not to be caught unprepared by further unforeseen events, the U.S. Space Agency, in agreement with ESA, is still working to get a launch window also for December 25th, always at 12:20 Universal Time. Regarding the different launch opportunities related to the particular orbit that will have to bring the Webb telescope to the Lagrangian point 2, daily launch windows of about a half hour are available, always at the same time. That is, at least until January 6th, when the position of the moon will modify the trajectories a bit and we will have to wait until January 13th to try again. But apparently we won't need it. On Friday the 17th, in fact, NASA announced that the problem had been resolved, and therefore the launch is confirmed for December 25th at 12:20 Universal Time. So much so that the technicians of ESA, NASA, and Arianespace are already proceeding with the closing operations of the fairing of the Ariane 5 launcher. Now, it's very close to the launch of the most complex and expensive space telescope ever produced by man. So this is the current situation, about 10 days before the launch. After years of waiting, the road seems to be paved, and the only threats that are still on the horizon are those of the many risks of the post-departure. But up to the time of the last incident, how did things go at the Guyana base? Let's try to reconstruct the chronology of all the operations that have been carried out since the end of November for the preparation of this historic launch. Okay, let's go. November 22nd, the first delay. An incident occurred during operations at the Satellite Preparation Facility in Kourou, French Guiana, performed under Arianespace overall responsibility. Technicians were preparing to attach Webb to the launch vehicle adapter, which is used to integrate the observatory with the upper stage of the Ariane 5 rocket. A sudden, unplanned release of a clamp band, which secures Webb to the launch vehicle adapter, caused a vibration throughout the observatory. The incident took place November 9th, but NASA did not disclose it until a November 22nd announcement that it was delaying the launch 4 days to conduct spacecraft testing. Agency officials did not mention it during a pair of November 18th briefings about Webb's telescope science goals and instrumentation, saying at the time fueling was scheduled to begin in a few days to keep the mission on track for a December 18th launch. So the launch readiness date for the James Webb Space Telescope is moving to no earlier than December 22nd to allow for additional testing of the observatory. November 24th. Testing confirms Webb telescope on track for targeted December 22nd launch. Additional testing was conducted this week to ensure the observatory's health following an incident that occurred when the release of a clamp band caused a vibration throughout the observatory. A NASA-led anomaly review board concluded no observatory components were damaged in the incident. Engineering teams have completed additional testing confirming NASA's James Webb Space Telescope is ready for flight, and launch preparations are resuming towards Webb's target launch date of Wednesday, December 22nd at 7:20 a.m. Eastern Standard Time. A consent to fuel review was held and NASA gave approval to begin fueling the telescope. Fueling operations will begin Thursday, November 25th and will take about 10 days. December 6th. James Webb Space Telescope fully fueled for launch. In preparation for launch later this month, ground teams have successfully completed the delicate operation of loading the James Webb Space Telescope with the propellant it will use to steer itself while in space. The vast majority of the launch energy required to send Webb to its operating orbit around the Sun-Earth Lagrange point L2 will be provided by the massive Ariane 5 rocket. Nevertheless, the observatory carries propellants of its own. After being released from the launcher, in fact, Webb will use its own system of small rocket thrusters to fine-tune its approach to its final halo orbit around the L2 point, where the telescope and instruments will cool in the shade of the enormous sun shield, protected from the heat of the sun, Earth, and Moon. Mid-course correction maneuvers for refining the trajectory are planned for 12.5 hours and 2.5 days after launch, with a third 1 month later to ease Webb into its L2 orbit. Those same thrusters will be used periodically throughout the mission to maintain that orbit, with small maneuvers called station keeping. A second set of smaller thrusters on the observatory compensate for momentum buildup caused by the pressure of solar radiation onto the large area of the sun shield. Although Webb is designed to keep that pressure well balanced, angular momentum builds up as the telescope points at different targets, so occasional small momentum unloading maneuvers are required to keep the observatory's reaction wheels within their proper operating ranges. Reaction wheels are flywheels in the Webb spacecraft that help keep the payload's orientation stable. Propellant loading was the final major operation for the observatory itself, before it moves to the final assembly building for integration with the Ariane 5 launch vehicle. But there is another challenging aspect not to be underestimated. One special aspect of processing the Webb Observatory at the launch site is the need to keep it clean. Unlike Hubble, whose telescope is enclosed in a protective tube, Webb can operate successfully with just the shade of the sun shield to protect it in space. While it is subject to the air on Earth, the environment around the telescope must be kept as clean as possible. This ensures that Webb's mirrors and sun shield are not contaminated with small particulates or molecular films, both of which could reduce the telescope's sensitivity. NASA, ESA, and Arianespace teams have cooperated very closely to custom clean the launch facilities to Webb's demanding requirements. NASA's Goddard Space Flight Center has also provided portable filter walls to augment the contamination control of the airflow near the payload. In order to make critical course corrections shortly after launch, to maintain its prescribed orbit nearly 1.5 million kilometers from Earth, and to repoint the observatory and manage its momentum during operations, Webb was built with a total of 12 rocket thrusters. These rocket thrusters use either hydrazine fuel or a special mixture of hydrazine fuel and dinitrogen tetroxide oxidizer. Webb's spacecraft bus, built by Northrop Grumman, was filled with 168 kilograms of hydrazine fuel and 133 kilograms of dinitrogen tetroxide oxidizer. Both fuel and oxidizer will be used together to maximize power for the biggest burns by Webb's secondary combustion augmented thrusters, which are for mid-course corrections and inserting into L2 orbit, as well as for orbit maintenance around L2 during the mission. However, hydrazine alone will be used for the small burns by Webb's tiny precision monopropellant reaction engine thrusters, which are used for large angle repointing and for managing spacecraft momentum. The fuel loading system was formally disconnected on December 3rd, followed by inspections and closeouts that concluded over the weekend. Combined operations between Arianespace and NASA teams preparing Webb and its Ariane 5 rocket are now set to begin. The next large milestones for the joint teams will be to move Webb to the final assembly building, place it atop its rocket, and encapsulate it inside its protective fairing. With final closeouts complete, the full stack of rocket and payload atop its mobile launch platform will be rolled out to the launch pad 2 days before its scheduled December 22nd launch. December 7th, Webb moved to meet its rocket. On December 7th, NASA's James Webb Space Telescope was transferred to the final assembly building at Europe's spaceport in French Guiana to meet its Ariane 5 launch vehicle. Stowed inside a special transport container and mobile clean room, Webb's vitals were meticulously monitored throughout the entire process of moving between buildings. The next steps ahead are to safely lift Webb to an upper platform, which has been prepared so that Webb can be connected to the Ariane 5's upper stage. After being connected to the rocket, technicians will move forward to encapsulate Webb inside Ariane 5's specially adapted fairing. December 11th, Webb placed on top of Ariane 5. On Saturday, December 11th, James Webb Space Telescope was secured on top of the Ariane 5 rocket that will launch it to space from Europe's spaceport in French Guiana. After its arrival in the final assembly building, Webb was slowly hoisted nearly 40 meters and then perfectly aligned on top of the Ariane 5, after which technicians bolted Webb's launch vehicle adapter down to the rocket. This whole process was performed under strict safety and cleanliness policies, as it was one of the most delicate operations during the entire launch campaign for Webb. A custom shower curtain, already installed between the two platforms where technicians worked to connect Webb to its launch vehicle, served as the walls of a clean room to keep the observatory dirt-free. The next step ahead is to encapsulate Webb inside the Ariane 5's specially adapted fairing. And with this, after the second postponement due to the incident of which we have already told you, we arrived at a week from the launch. We just have to wait a few days, and on Christmas, we will know if the God Projector of space and spaceships will decide to bring us coal or the extraordinary gift that we've all been waiting for many years. Merry Christmas to you all, no matter what happens.